OPPS, or object-oriented programming, is a programming paradigm that uses objects, which are instances of classes, for organizing code. It is based on several principles that promote a modular and organized approach to software development. The main principles of OPPS include encapsulation. Encapsulation involves bundling the data, attributes, and methods, functions, that operate on the data into a single unit, known as a class. This helps in hiding the internal details of how an object works and exposing only what is necessary. Inheritance. Inheritance allows a class, subclass, derived class, to inherit the properties and behaviors of another class, superclass, base class. This promotes code reusability and establishes a relationship between different classes. Polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass. This can take the form of method overloading, same method name with different parameters, or method overriding, same method name and parameters, but different implementation in subclasses. Abstraction. Abstraction involves simplifying complex systems by modeling classes based on the essential properties and behaviors they share. It allows developers to focus on the relevant aspects of an object while ignoring the irrelevant details. OPPS is important for several reasons. Modularity. OPPS promotes modularity by organizing code into reusable units, classes and objects. This makes it easier to understand, maintain, and update code. Reusability. The concept of inheritance allows for the creation of new classes that reuse the properties and behaviors of existing classes. This reduces redundancy and promotes code reuse. Flexibility and scalability. OPPS makes it easier to adapt and extend existing code. New features can be added by creating new classes, and existing code can be modified without affecting the entire system. Maintenance. Code that follows OPPS principles is generally easier to maintain and debug. Changes to one part of the code are less likely to impact other parts, reducing the likelihood of unintended side effects. Collaboration. OPPS promotes collaboration among developers. Different developers can work on different classes or modules simultaneously, and the overall system can be assembled from these independent components. Overall, OPPS provides a framework for designing and organizing code that leads to more efficient, scalable, and maintainable software systems. Many modern programming languages, such as Java, C++, and Python, support OPPS concepts. Salesforce development heavily relies on object-oriented programming, OPPS, principles, as Salesforce is built on the Force.com platform, which is inherently object-oriented. Let's go through each of the object-oriented programming, OPPS, concepts: encapsulation, inheritance, polymorphism, and abstraction with simple examples in the context of Salesforce Apex. 1. Encapsulation. Definition. Encapsulation is the bundling of data, attributes, and methods, functions, that operate on the data into a single unit, known as a class. In this example, the account handler class encapsulates the data related to an account name and account balance, and provides methods to interact with that data: get account balance, deposit money, withdraw money. The data is private, and external classes can only interact with it through the defined methods, ensuring proper control and abstraction. Inheritance. Definition. Inheritance allows a derived class to inherit the properties and behaviors of another base class. In this example, the dog class extends the animal class, inheriting the makeSound method. The dog class can override the method to provide a specific implementation. Instances of the dog class can also call the fetch method. This demonstrates the reuse of code and the ability to extend functionality. Polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass. It can take the form of method overloading or method overriding. In this example, the shape class has a method calculateArea, and both circle and square classes override this method to provide their specific implementations. You can then treat instances of circle and square as instances of the common superclass shape when calling the calculateArea method. Abstraction. Abstraction involves simplifying complex systems by modeling classes based on the essential properties and behaviors they share. In this example, the shape class is abstract, meaning it cannot be instantiated directly. It defines an abstract method calculateArea. Concrete subclasses like circle and square must provide an implementation for this method. This enforces a common structure for all shapes while allowing specific shapes to implement their unique behavior. These examples illustrate how encapsulation, inheritance, polymorphism, and abstraction are applied in Salesforce OPPS, providing a foundation for building modular, reusable, and maintainable code.